So now we're gonna go through the process of setting things up in Fusion 360 to CAM, the part. So CAM is computer aided manufacturing. This is how we develop the tool paths needed for the part to be cut out on the CNC router. So the first thing I'm gonna do in the part management system, let's go ahead and do this from the top where we put things into the part management system. So let's go ahead and do the shooter plate. This is going to be the first item in C. Let's change C to arm shooter, and then D is actually going to be intake. So changing our part management system based on how we're designing right now. Arm shooter, first part number, Control Shift V there. Go back to my arm. It's gonna be, we're gonna make this a 1/4 inch. Let's do this in polycarb, a 1/4 inch polycarbonate plate. So we're gonna need 2 of those. Remember, they're flipped. One has the motor on the top side, one has the motor on the bottom side. I did this so that we could have one plate that could do both sides, but not necessarily wasting material to where we have like a second mounting hole on the other side of the shooter plate. That's another way to do it, but we decided to do just one side now and just flip it on the other side, which is cool, which is fine. So then let's see, what else do I need to do on the part management system? This is shooter plate, not obsolete. It is going to need a DWG. It's going to have the same part number for the file name, and this is a 1/4 polycarb. We need 2 of them, and they're going to be on the CNC router. Okay, and then from here, I'm going to need to export this as a export DWG. This is going to be shooter plate, bringing in the part number. Okay, so in export, what do we want a DWG? I did the wrong thing here. There's 2 type of export options. There's export and there's export DXF DWG. We want this one right here. That's going to allow us to get that 2D shape of the front face. Same thing, name, DWG, download, good to go. Now I'm going to go to my Google Drive. Now let's go to the UNLV Mentor Shared Drive, Fall Course, Robot Design, Film Material, cool. And then so that file that we just exported is going to go into the part files section. That way, if I design it, but somebody else is on the fabrication sub team, they could download it from Google Drive to do the fabrication. So if I'm on the design team, I'm just exporting all these files, and then the fabrication team is downloading them and using them to do whatever process they need to do afterwards. We also need a drawing for this part. So right-click the same part, create a drawing of the shooter plate. Use the 24 UNLV drawing template. Let's see if this is small enough to fit 1:1 on a page. I don't think it is. So let's see what it looks like when it's 1:1, and let's do the right face. Oh, it might be. All right. So boom. And boom. Cool. So it is large, small enough to fit on one page. Let me show you something real quick that also helped. Like this thing was designed at an odd angle, so it's bringing in the view from that angle. So if I go to that arm part studio, it is giving me the view directly from the side view of that part studio. So if I go on the right side, it's giving me the part at this angle. If I say like take this front face and I press N for normal, I'll look straight down the side of the plate, kind of if I was looking straight down the shooter subsystem, right? If I click this cube and then I go to named views, and I'm going to call it shooter front, and I'm going to add this view. Okay. Now if I go to my drawing again, I can double click this guy. It'll open up a menu over here, and in my view orientation, I think I need to drop in a new one. So let me go ahead and remove these guys. Insert view. I want to insert my shooter plate. Current document, shooter plate, 1:1, and then my view orientation, now it's uploaded shooter front. And that should give me a little bit smaller of a projection of that view. There we go. So now it fits better on the paper. So what would the fabrication team want to know? Well, they'd want to know how big of a piece they need. So I'm going to do top and bottom. Boom. I'm going to do thickness so they know what material to grab. And then I'm going to press M, which is a dimension tool in drawings that's maximum or minimum. So I'm going to go from the front. Actually, no, the maximum is at some straight lines here. Usually if there's like a curved feature like this and you want to dimension like the highest points here, you'd use maximum and minimum. But since the front and back face have these straight lines, I should be okay just to use the regular dimension tool. Okay, so we need to have a part that at least has an area that's like 7 by 7 in terms of inches of cutting surface that I need, and then a 1/4 inch polycarb plate. The thing that I forgot to do was to do the properties. You see how this is now empty? That's okay. I can go here, shooter plate, go to my properties. I can open up my part management system, grab part number, and I'm looking for arm part number. This is revision 1. Title 1 is material, so that's 1/4 polycarb. 2 is quantity, so that's 2, and then 3 is process, so that's CNC. I go ahead and save that. I go back to my drawing, and now it shows. Now that circle in the upper left is yellow, meaning that there's something to update. So I click that, and now if you watch the part data down here, it fills in V1, CNC process, 1/4 inch polycarb, 2. So now this is ready to go for the fab team, so they know they have to make 2 of these. I forgot to mention this previously, so I'm going to splice it in here. Other things that the fabrication team might want to know are things like this hole size. They can confirm that's a bearing hole size by looking at that. This hole size, so that'd be a shaft pass through, and then these hole sizes here, just to confirm that we're using the 201, which that would be the 5mm drill bit that we would use to do those. So it'd be important to do the interior dimensions in here as well, just so the fab team knows what tools they need to grab. And I mean, typically it's just the 5mm drill bit is what, or the milling bit is what we use for all of this, but for them to confirm, they can look at this information here. Right click, export. We are going to want the part number, and then part number dash part name. It's currently being exported. This is going to be in PDF drawings. Once this is downloaded, it's going to drop down in here. Now, last thing I need to do to finish up this part management section is to link the files here. So that's going to go shooter, share, copy. This is the PDF drawing, insert link, paste it in there. Part file, DWG. This is the shooter plate, share, copy link, and then paste it in here. Boom. Cool. So now I have all of the stuff that the fabrication needs to do this. So as a design team member, I did my job of putting in all the information for the fab team. Now from the fab team now, I would go in and I'd download these files. I'd look at the drawing, see how many I need. I'd look at the part, see how the area of polycarb that I need to make this. I would download the DWG. Once I download the DWG, I would open up Fusion. All right. So now that now that I have my Fusion open, I'm going to upload, select files, and then I'm going to go to the shooter plate DWG that I just created, and then I'm going to upload that. And then once that's uploaded, you'll see it populate here on the top left. All right, so now the file is uploaded. I can open it up on Fusion. It'll load like this. It's just the 2D shape, and then so from here, I'm going to move from the Design tab to the Manufacture tab. So the first thing when I'm in the Manufacture tab, I'm going to set up my workspace. So I'm going to go and create a new setup. I'm going to first change the stock to be a fixed size box, and I'm going to change the height to 0.25 inches. I'm using like a 1/4 inch piece of polycarb. Here you actually take calipers and measure, so it's typically a little bit less than 0.25. Usually it's like 0.235 something. But that would be the measurement that you get from the calipers from actually measuring the stock you're using. Next, in the setup section, let's change the coordinate system so that it's a little bit friendlier. I want the x-axis to be along like the face of the part, kind of similar to what we do with the drawing. I'm going to select my x and y axes. My x-axis, I want to be this guy here. We know this line is like perpendicular to like the shooter mounting tube, so I'm going to choose that as my x-axis. And as you can see, like it very heavily reduces the amount of material needed to cut this part. And so here, I'm going to also change the stock point to be the bottom left corner, because that's going to allow me to, when I zero it on the machine, I'll be able to do like a quick XY sweep to make sure that the stock that I'm using actually fits the part that I'm trying to make. So that's good. I've changed my thickness. I've changed my coordinate system to reduce area of the part on the material, and then I've changed my box coordinate to be bottom left, and then also the top surface is what you want here. You want the bottom left corner top surface of your material. So my setup's done. Next, I'm going to start cutting out these internal features. General workflow is internal features first, external contours last. Holes, like just straight drill holes, which are all the 201 holes, do first. And then second is going to be the large holes. And then final sweep is going to be the exterior. So first thing I'm going to do a drilling operation, select my tool. The tool that I have is a 5mm, it's a 5mm single flute bit, which I think is in the shop computer, so it's not here. So I'm actually going to add this tool. Going to library, add tool. It's a flat end mill, and then it says 5mm single flute. Vendor is going to be WCP. Cutter, it's going to be flat end mill, millimeters. 1, it's carbide. 1 flute. Diameter is 5mm. And then overall length, let's see if we can find the actual part. So it's this guy here. This is the one we're using. So do we have any information about this guy? 12 millimeter cut length. Okay, so that means we know flute length is 12 millimeter. I'm going to put in some numbers in here just because the actual numbers are in the shop and I'm doing this at home. But essentially this is already created. So let's get this all sorted out first. So I'm just going to put in some numbers that are relatively okay. Overall length must be greater than length of below holder. So let's say that there's 20 below the holder. Let's say that there is 15 below the holder. Shoulder length is 13. Cutter is 12. Okay. Cool. So this is my part. Single flute, carbide, flat end mill, 5 millimeters in diameter, 12-inch cut length, and the rest are kind of like guessed based on having seen the bit, but you'll have the real numbers in shop. So I'm going to do this 5 millimeter single flute as my cutting tool. Oh, as well as all the presets for that tool are also included in there as well. So let me edit those. So the single flute, I'm going to go into edit that part. So library 5 millimeter single flute. Let's go ahead and edit the data. Spindle speed is going to be 2600 RPM is the speed of the CNC router. And then the cutting feed rate is going to be, I think 100 inch per minute. And let's confirm that real quick. So back, we're going to go to the Omeo. They have a manual on the website. And so if we're looking here we go. So, okay, so it's actually 2400, so I'm going to change that. Feed so something between 60 and 120 is typically good for aluminum. These numbers can be doubled or tripled for softer material like polycarb, like the one we're doing. And then depth of pass. Okay, cool. So, all right, so I like my numbers. This is going to change to 2400. And then 100 inch per minute here is fine. And then I think we're good here, except. So now when I look at my my tool path information here, my drilling path, my RPM is changed, my speed rate, or my speed is changed. Next, I'm going to select the geometry that I want to drill out, and I'm going to select the points. So this is going to allow me to just select the centers of each of these holes. And these are all the holes that are that 0.201 diameter that we did in the design. Depth, for the drill depth, I'm going to do this bottom height. I'm going to change this to lowest selected, stock bottom, and then I'm going to make an offset of 0.0125. And so what this is going to do is it's going to tell the drill bit to go from the top of this origin here. It's going to go the depth of the stock, so it's going to go until the stock bottom, and then it's going to go a little bit past it by 0.0125, and this is going to allow us to go through the part barely into the spoil board underneath, but it'll make it so that we definitely go past the part if we've zeroed on top of the surface correctly. So that's drilling the holes. Next operation, we're going to do a 2D contour, and then we're going to select the same tool, 5 millimeter single flute. Okie dokie. And then we're going to change the cutting feed rate to 200 because this is polycarb. It's much softer than aluminum, so we can go a bit faster. I'm going to do all of the geometry, all of the larger holes now. Now, when you do 2D contour, something that you have to consider is the location of these red arrows. That'll tell you what side of the geometry the drill bit will be in. So this tells me that the drill bit will be doing its path inside of the circle, which is what we want. We don't want it to be on the outside of the circle like this, because then we'll be cutting out this additional material on the outside. So interior contours, red arrows are inside the part. Heights are going to be the exact same thing. I'm going to go to bottom height, lowest point selected, stock bottom, -0.0125. And then for these 2D contours, because the drill bit is going to be moving as it's cutting, we also have to tell it the depth of the cut. So I'm going to go to this multiple depth section here. I'm going to change this to 0.1. For polycarb, 0.1 is what I typically use. If I'm doing like aluminum, I would pick something like 0.05 or 0.04 or 0.06 if it's a really small part and it's not going to get too hot. But 0.1 for polycarb works fine here. And then I will select OK. And now it should create my tool paths. You'll see that these red or these blue circles indicate the path that the drill bit's going to go on. So I can actually simulate what it's going to look like if I select both of these tool paths. I press Control to select both of them. I have the simulate with machine button here. I'm going to play that. And that's going to allow me to play, and this is the speed slider, so you could change the speed based on how fast you want to view the simulation. But you can see the drill bit actually moving in each of these contours that it's making. So those will be the interior passes. That looks fine. And then I'm going to do one final 2D contour, and this is going to be on the outside. So I'm going to do it'll pull in, because I did a contour before with the right tool settings. It'll pull in the tool settings from the previous contour, which is fine. It has the 200 inch per minute feed there, which is good. Geometry, I'm going to do exterior contour. Here I do want the drill bit to go on the exterior contour because this is cutting out the part. We want everything inside of this shape to be kept, and so the drill bit is going around the outside of this part. Next heights, same thing, bottom height, lowest selected, stock bottom, change this to -0.0125, passes, multiple depths, change this to 0.1 because it's polycarb and it's soft, and then OK. Cool. So now I can see actually the whole tool path. I'm going to simulate, and then it's going to drill all the holes. It's going to do the contours. So one thing to note, because it's a 1/4 inch thick here and we're doing 0.1 inch drill depths, it's going to do about 3 passes to get through the entire material. So it's going to go down 0.1, drill out, 0.1 again, drill out. So that's 0.2 now. And then it's going to go the final 0.5 plus the -0.0125 to get down to the rest of the material. So that's why one of the things I'm looking at when I'm watching the simulation is that it's doing the amount of tool paths that I expect it to based on the selection for drill depth. So I'm also confirming here that it's drilling on the outside contour, and it did 3 passes, so that looks good. And now I'm going to export this in two different file drops. So first, I'm going to take both of the inside contours, and then I am going to post-process. It's going to open up this new window. Mach3 is the post-processing that we use for the OMEO. So make sure you select Mach3 here. File name, I just put the part name, and then I put whether it's the interior holes or the exterior contours, because those are going to happen in 2 different tool paths. So this is shooter plate holes, and then I'm going to go ahead and let's put this in a different folder. So I'm going to go desktop. I'm going to create a new folder called CNC files. Already contains, oh, I already have one. So let's go ahead and rename it. Fall 24 CNC files. Cool. So select this folder, and then this now should download directly to that folder. Going to do the same thing with this exterior contour toolpath. So I'm selecting the toolpaths that are being exported. Same thing, post-process Mach3. Now this is shooter plate contour, going to the same Vol24 CNC files. And then I'm going to go to that folder, Vol24 CNC files. And then the next couple things I'm going to do before I actually put it on the Omeo is I'm going to remove a couple of lines from the G code because these lines are making the drill bit go into the material before actually cutting, which I want to prevent. There is probably a better way to do this by selecting some options, but this is what I have working so far. I'm going to open up the shooter plate G code. Let me close these other files. I'm going to delete on the top of my file. I'm going to look for the thing that says G28 G91 Z0. I'm going to remove this. I think this is supposed to move it to a 0 in the the tool coordinate system, but for some reason this is making it go to the top of the part, which I'm going to remove. And then I'm going to remove this G28 91 Z0 all the way to this XYZ0 here. I'm going to remove all three of these. Control S save, and then close. And then same thing with this shooter plate holes. Open a notepad. This G28 G91 Z0, delete that. Then G28 91 Z0 all the way to G28 91 X0 Y0, delete that. Save, close, and now these files are ready to open in Mach3 on the CNC router computer for cutting.